Finally, and this is perhaps quite a deep point, he says, the human being, in the same way as a human being will call the direction upwards, the direction opposite to the field of gravitation, to the local field of gravitation, that he will call upwards. See, finally, we know that the antipodes, the people at the other side of the earth, they don't walk on their head. They also stand on their feet because their local gravitational field is in the opposite direction. So, Boltzmann says, just therefore as a human being adapts himself or his sense for the vertical direction by the local gravitational field, so perhaps he adjusts his sense of the arrow of time by the regression of this limited portion of the universe in which he lives towards equilibrium. Well, I don't really know. This argument has been discussed by many people, and some people say, if you really think about it, it must be nonsense. I don't know. It has always had great appeal for me. But one must admit that at present it sounds rather old-fashioned. And well, for two reasons. First reason. Since the cosmological papers of Einstein in the late, around 1920, and since the discovery of the redshift of the nebula, the fact that all these distant nebula seem to run away from us faster and faster, and the other really spectacular developments of the observational astronomy, nowadays one speculates and theorizes not only over a portion of the universe. We think we know the whole universe, everything. It may seem a bit presumptuous, perhaps, but it certainly is the present tendency, and it seems to be fruitful, at least so far as one can say. Therefore, the idea of Boltzmann that we have to do with only a small portion of the universe is, as I said, old-fashioned. We observe the whole universe. A second argument against Boltzmann is a much more recent origin also, and has much more, still more deeper implication. There seems to be observational evidence that there is an origin in time, a beginning. I must say this is still a controversial matter, and I am far from an expert in it. But still, when one hears about it, it is very remarkable that various arguments, seemingly having nothing to do with each other, quite independent of each other, seem to point to a kind of singular point in the development of the universe, which is about 6 billion years ago. Well, take on 1 or 2, that makes no. It has unfortunately the tendency to creep up. It gets longer. Every time they make the observations better. But still, let us, for the sake of argument, call it therefore that there seems to be a beginning of time 6 billion years ago. Let me just say shortly what the arguments are. Several of the main arguments have to do with radioactive dating, which are quite technical, but which are again in agreement with each other, and all pointing to about this date of the beginning when the original elements were formed. The second argument comes just from the redshift itself. You know that the Hubble found that these nebula ran away from us with a velocity which is proportional to the distance to us, which is very strange. we don't like to be in the center of the universe anymore. It's against the humility principle. I don't want to review to you how you can get around and answer this objection. You can, namely, by using the general theory of relativity, show that one can think of it that the universe expands and that therefore the change of distance is only apparent in a sense and would be the same wherever we were. In any point of the universe they would find the same, which is very much more satisfactory. However you explain it, either naively or sophisticatedly, it still is obvious that if they run away from us with this big speed, then you can ask, where were they earlier? And so you can extrapolate backwards. And then you find that all these nebula would be practically on top of us 6 billion years ago. There again you would have therefore an argument that around this time there was a kind of a singular state of the world. Mind, the whole world. Nothing excluded. Now, let us therefore see now that with regard to these questions, whether what one now can say with regard to the speculations of Boltzmann. Well, as I said already right away, that if we really think that we look at the whole universe, then it is of course wrong to think that the little piece that, well, since the little piece is really the whole thing, that cannot be a fluctuation away from equilibrium, while the whole thing was in equilibrium, which was one of the starting points of Boltzmann's speculation. So, then you would say, the universe, so to say by definition, I will come back to this point because some people will object against this, but one would say, what else can the universe be than a closed system? Because if it weren't closed, then what is outside is also part of the universe. And that is therefore, how can it be else than a closed system? And then you can therefore ask again, how does it come now, if it is a closed system, that it is not in equilibrium yet? And that we are not again in this terrible state of the heat death, in which is a synonym for complete death. But now, of course, the thing changes if there is an origin in time. There is, as I said, for that, a strong evidence, besides these things I mentioned, comes also from the biological evolution theory, which points not to 6 billion years ago, but still to times, say, 3 billion years ago. There is also very strong evidence for a cosmological evolution. The work of Bade and of the Pasadena School of nuclear physicists, they have shown that really one can still see the formation of new stars and star systems and see how they are formed and go through their evolution. And one can see, so to say, before one's eyes how the elements are formed, so that some stars are formed with very queer elements which don't even exist on the Earth. And in this way, one has come to a kind of chronology of the development of the universe. I am, as I said before, a dilettante in this, and I really have no critical opinion, but I must say that if I hear Bade, which I heard just recently, and other experts in these matters, I'm extremely impressed. I mean, one begins to see a kind of whole time scale for the whole universe, not only for the geological periods of the Earth, but the formation of the solar systems and the nebula and the elements, and they all know precisely when it happened, one after the other. And that is not a fiction, because they have all kinds of various argumentation which seem to lock together, beginning to evolve anyway. Well, it is clear that if this is true of this origin in time, then the character of this problem, why we are not in equilibrium, the problem of the heat death, changes completely in character. In fact, and here I want to mention a rather technical point, but for me rather interesting, which was pointed out by Landau, the Russian physicist. He mentioned the following: if the universe is really expanding, as the redshift observations indicate, then he says, you must not think really of the universe as a closed system. The overall gravitational field of all the matter, they say always, must be looked upon as a kind of an expanding vessel in which the whole material universe is enclosed. If you took a gas in a vessel which all the time blew up, then it is clear that that gas could never be in equilibrium. And Landau suggests that this might be the reason why the universe is not in equilibrium, is prevented by the expansion to it. The objection which one would think is why the overall gravitational energy is treated different from the other forms of energy. According to Landau, this is necessary to do because the overall gravitational energy will not take part in the general equipartitioning of energy, which is characteristic for the equilibrium. And well, for the reason that if you include the gravitational energy, the whole law of conservation of energy becomes an identity, so to say a tautology, doesn't say anything anymore, and cannot therefore govern the change of the states. Well, I only want to mention this argument. It is contained in this recent book of Landau and Lifshitz on statistical physics, and I think it has to be analyzed more, which I haven't done, but might be another important suggestion. Anyway, if there was an origin in time, and even if we forget these doubts of Landau, and let us still think that the universe is a closed system, then perhaps just this existence of an origin in time is already enough reason for the fact that the present universe is still in the full process of evolution. Perhaps the 6 billion years was by far not enough time to get to equilibrium. We are still in the beginning of something, perhaps. You see, the real worries at the time of Boltzmann about the heat death had certainly to do with the fact that in those days people had no ideas how long it took sometimes for a system to go to equilibrium. We since then have learned much more about certain situations in which it takes millions of years, in fact we cannot observe it in the laboratory, that the system really goes to equilibrium. It takes that long. I want to mention here one example of that type, which I always think is so instructive. You see, if you make solids, crystals, and you try to make them exactly the same, as much as possible, same substance, same shape, everything the same, they never are the same. They show an individuality shows itself in some properties, not in all, but in some properties. They call them the structure-sensitive properties. And they are quite different in these properties. And it looks, therefore, that these different crystals, which we look the same, still have a perfect individuality, individual properties, which cannot be quite repeated. Now, you would say, how is that possible? Wait then a little while, you say, and then they will go to equilibrium, and then they will all be the same. Well, you can wait till doomsday. Never happens. Takes so long. Nobody has observed a real change in observational possible times. The explanation of this strange fact is again from rather recent times. It is due to the fact that all crystals contain imperfections in which whole rows of atoms have slipped from their proper positions. They call them Taylor dislocations. And these deviations from equilibrium cannot be considered spontaneous fluctuations from equilibrium, since they would correspond to such large deviations that the probability would be absolutely negligible. These defects the crystal acquires at birth. And again, that requires a lot of explanation how it comes then that a crystal with a defect somehow seems to grow better than a crystal without defects. But it is a fact, he grows better, and therefore he suppresses all his perfect brothers. I don't want to further talk about this example. It clearly leads to rather obvious speculations about the origin of the whole concept of individuality, another philosophical problem. On what is the human individuality based? Maybe that is also based on defects with which we were born. And each one has his own defects, therefore we are all different. But the thing which I want to stress here is that here we have really an example of deviations from equilibrium which take really extreme long times before they would settle to equilibrium. I think it is therefore not remarkable that 6 billion years ago, which seems rather long, is still a short time for the evolution of the universe. The scientific task for the physicist and also for the biologist, I think, is in the future to understand these enormously different relaxation times, and especially in statistical physics, which is the field I'm most acquainted with. I think it is becoming more and more the central problem to understand the various rates with which processes go to equilibrium and the effects these rates have on the description of macroscopic systems. Finally, if there is an origin in time, one always must make this statement, but because I want to impress on you that it is not accepted by everybody. It is only accepted by part of the astronomers and physicists. Well, if there is an origin in time, then perhaps the last part of the speculation of Boltzmann can be maintained. The whole biological evolution, our consciousness of the arrow of time, is perhaps just a reflection in us of the evolution of the whole universe. Sounds a bit grandiose. And also, perhaps for the taste of many of the present-day scientists, a bit too close to the religious conceptions of the Creation Act. One must, of course, say that this is not an a priori reason why it should be nonsense. However, I must admit myself, that it makes one a bit uncomfortable, especially this combination of these two features, that basically the basic laws of nature would not show the arrow of time, would therefore have no preference for the future or the past. But that this arrow is, so to say, superimposed by a very special initial condition, namely the initial explosion of Elam, of the primordial matter. I find this unsatisfactory because of the lack of uniqueness. I would like it much better if the basic laws of physics would then also take part in the whole gigantic evolution, so that the reversibility in time that we observe in the laboratory would then only be valid if we don't observe it for too long a time. Or in more mathematical language, it would be valid in the small. But in the large, it might be that the basic laws of nature would still show the arrow of time themselves, only so feebly that we can't see it in our laboratory. These ideas have really been maintained, and especially Dirac and other people have speculated in this direction with regard to the question whether the fundamental constants in physics, like the velocity of light, the Planck constant, the charge of the electrons, are they really constants? How do we know that they are constants? Will our grandchildren find the same values if they make the observations? Or will there be perhaps a very small change in the values, and that change would then again reflect the evolution of the whole universe? Well, I want to close such speculations because they may sound or rather scholastic or vague to you, and they are certainly deep in the sense of Bohr. For those who don't know what deep is in the sense of Bohr, let me tell you that he calls a deep statement something in contrast to a clear statement. You see, a clear statement, the opposite of it is either true or false. But the opposite of a deep statement is again a deep statement. Well, that I have brought up these such speculations in general, rather for a physicist and also for me, at least, rather unusual kind of ways of thinking. I have a few excuses for it, and I would like first to mention to you one excuse. I remember very vividly that I had once a very long discussion just about these questions with Frank Carlson. I must admit, we did that after we had something to drink. But it was and I will never forget this discussion. And the other excuse is, I think that such speculations will perhaps convince the non-scientist among you that physics is not only a kind of a technical subject, mainly with more or less useful or useless or dangerous or not dangerous gadgets to make, but that at its best it has as its goal the same as all the other sciences, namely to understand the world. Thank you.
But a wiggly set for backing up. The slack left the rope slowly, and the tractor faltered under 800 pounds of hay. Pop, 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 pop. The big engine ran so slowly I could count each explosion. Then the governor overcame the hesitation, and the hay rose steadily from the rack. The huge rope was drawn straight, and it trembled under the strain. Suddenly, the rope went slack. I knew the pulley had snapped into the carrier, and the hay was sailing down the track. Have to get ready now. Have to get ready. George'll holler any.
Whoa,
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 whoa!
whoa!
George yelled. I grabbed the clutch lever, and gone. It swung freely on its mount. I thrust it forward and yanked it back again. It was totally disconnected. I jammed both my feet on the brakes. With the tractor in first gear, the brakes were useless. In a frantic effort to stop the machine, I kicked violently at the gear shift. The tractor stopped almost instantly with a dreadful grinding noise. And at the same time, I heard the wrenching of timber high in the barn and George shouting madly.
I knew the